One of the goals of the It's Our Air video series is to present a variety of viewpoints on air quality issues in North Carolina. All the opinions expressed in this program are the personal views of the student participants and interviewees, and not necessarily those of the North Carolina Department of Environment and Natural Resources Division of Air Quality, any other state government office, or any of the sponsors of this program.
It's up there. You know, the atmosphere. You see the clouds, you feel the weather, but there are things you don't see. Gases, pollution. Those things can affect you too. It's time to take a deep breath and figure it all out, because it's our air. Oh wow, I can see my house from here. Oh. Our topic today is combustion. What is combustion? Does anyone know?
When something burns.
Yes, when something burns. And do you know why we're going to talk about burning things today?
Because burning can cause air pollution.
Burning can cause air pollution. In fact, almost all air pollution is generated by the burning of organic materials, like wood, and fossil fuels like coal, gasoline, and natural gas. The main reason we burn these things is to produce energy to power our homes and our industries. Oh, and commercial buildings, and cars, and trains, and planes. The problem is, the more combustion-based energy we use, the more air pollution we produce.
So when we ride to school, or mow a lawn, or buy a product that was manufactured and shipped to a store, we are contributing to air pollution because combustion is the energy source behind all those things.
But what actually happens when something burns? What is the process of combustion? Combustion is a chemical reaction that occurs between fuel and oxygen. The reaction causes the atoms in the fuel and oxygen to combine into new kinds of molecules. And, just like any ordinary chemical reaction, the law of conservation of mass applies. You might recall that mass cannot be created or destroyed, but it can be rearranged in space and changed into different types of particles. So when you burn that log in the bonfire, it's not exactly gone. It's just that all the molecules that originally made up the log have been turned into different molecules.
The main thing to remember when you're thinking about combustion and the law of conservation of mass is that all the stuff that goes into making combustion happen is still there after it happens. It's just in a different form. For the most part, the atoms that have been here on Earth since the beginning are still here. They've just been changing from one thing to another through chemical reactions, such as combustion. Some of the atoms in your body could have been part of a dinosaur, a rock, or even a flower millions of years ago.
Almost all of the fuels that we use are hydrocarbons. Those are materials that contain both hydrogen and carbon atoms. Let's take a look at one of the simplest hydrocarbon fuels, methane. When you add oxygen and a spark, you get combustion. But after combustion, we need to have all those hydrogen, carbon, and oxygen atoms accounted for. The hydrogen combines with oxygen to form water vapor, and carbon combines with oxygen to form carbon dioxide.
You can write that down as a simple chemical equation. You've got the molecules that are reacting here, methane and oxygen. Combustion is shown here, and the products of combustion go here, water vapor and carbon dioxide. This is complete combustion of methane and pure oxygen. But that's not how it happens in the real world. It's a lot messier there.
After all, most fossil fuels aren't pure hydrocarbon, and most combustion takes place in the air, which isn't 100% oxygen. In fact, oxygen isn't even the most prevalent gas in the atmosphere. Who remembers what is?
Nitrogen.
Nitrogen.
78%.
Yes, 78%. That nitrogen's got to be accounted for somewhere in the combustion equation. When you burn methane in our atmosphere, combustion produces nitrogen oxides, or NOx, and carbon monoxide, in addition to the carbon dioxide and water vapor we already knew about.
Methane gas is a very simple hydrocarbon fuel, with only hydrogen and carbon to add to the atmosphere. There's a lot of methane in our atmosphere, loads more in the Earth's crust, like in natural gas, which is mostly methane.
Other fuels contain other atoms besides carbon and hydrogen. Coal, for example, can contain sulfur. These atoms get thrown into the combustion mix and can become air pollution. Sulfur can become sulfur dioxide. Remember that before burning, sulfur is bound in solid form, but after burning, it goes into the air and starts moving around, where it causes pollution problems.
Sulfur dioxide in the atmosphere helps cause acid rain and particle pollution. Acid rain can damage streams and forests in the mountains, and can eat away at stone buildings and monuments. Particle pollution is bad for our health.
All right, let's go burn some stuff. Different types of fuels create different types of pollutions based on the substances they contain. Of course, some fuels burn cleaner than others because they have fewer impurities. What we're going to do is we're going to burn two different fuels so you can see the difference between them. All right, first I'm going to go ahead and light up the candle. Now the candle is burning the wick and, of course, a little bit of the wax. I'm going to take this mirror, hold it down here over the candle. 1 Mississippi, 2 Mississippi, 3 Mississippi. And you can see a gigantic black spot, about quarter size, where the candle has burned. Alex, if you could hold that for a minute. I'm going to grab our other fuel source, the butane torch, and hold that up to the mirror. 1 Mississippi, 2 Mississippi, 3 Mississippi. And what you can see, or rather what you can't see, is much of anything. The butane torch, the butane's a cleaner fuel, less impurities, very, very little smudge compared to what the candle left behind. Combustion's an important part of our everyday lives. It heats our homes, it cooks our food, it runs the cars and buses that take us to school, it generates electricity, it even takes us on vacation. In fact, there's not a lot that happens in our modern lives that isn't dependent on combustion in some way. But combustion is also the main source of pollution in our air. Something to think about.
Combustion is everywhere. It's in everyday life. Everything we do, almost can't get away from it.
I think combustion plays more of a role than we know. A lot of people depend on it without realizing.
Well, the things I do contributing to air pollution obviously doesn't make me feel very good. It's kind of a realization that I need to be doing things differently.
I do want to help the environment, but all the same, I think it'd be really hard to give up hot showers.
I'll be honest, since I've been driving, I'm not willing to give up my car. I'm just not. It's such a source of freedom.
I don't know how I'd feel about not using my laptop anymore.
I would not be willing to give up my phone, seeing that I use it so much and text so much.
If that got taken away, I don't know, because myself was my life.
Honestly, I do not believe I could get by without combustion.